please do ask questions if they do need to be asked. All right, so have you guys gotten into the habit of minus negative is really plus a positive? Hope that if you notice that, you go through and you mark that right away. Bless you. So negative 11 plus 4 is negative 7. Negative 7 plus 6. Oh, that's hard to see, isn't it? Negative 7 plus 6 is negative 1. And negative 1 plus negative 15, I got negative 16. You guys all right with that?
Yeah.
Joe.
So why wouldn't you, like if the 6 is in the parentheses, so why wouldn't you distribute the negative on the outside of the parentheses?
We kind of are. There's only one thing in there. There's just a negative 6. So remember, distribution is multiplication. So we're essentially saying that a negative times a negative is a positive. Does that make sense? There's only one term in the parentheses. If there was two terms, like if it was 4, if it was 4 minus 3 minus 6, then you could distribute that minus sign maybe.
Oh, I see what
4 minus 3 plus 6. But because there's just one, since there's just one term in the parentheses, we probably wouldn't call it a distributive property, even though you sort of kind of could. It's really not that.
I just didn't make the 7 a negative on accident.
Oh, okay. Gotcha. Okay, so number 1 was all one operation. Essentially, it was minus and plus. Number 2, like yesterday, has a lot more involved. There's all kinds of operations, and so reading from left to right doesn't make sense here. You got to use the order of operations.
What's the answer to number 1?
Negative 16. Everybody out, please. Thank you. I want you 100% focused, not 50. So the answer to number 1 is negative 16, right? I can look at. Oh, you turned this into multiplication. It's not multiplication. It's 4 minus negative 6. So it should be 4 plus 6. Okay, so I got to use order of operations here. I'm going to do the work in the parentheses first. So let's see here. In there, I got 3 times 2, and that's 6. Minus, what's the absolute value of negative 9?
9.
So it's 6 minus 9 in the parentheses there, plus 5. And 6 minus 9 is negative 3. So for my next step would be 4 minus 3, parentheses, negative 3 squared plus 5. Look at what you have. Look at what I have. See if there's any questions as we go through this. Okay, the next thing is I've got to do my exponents. Negative 3 in the parentheses squared is 9. So 3 times 9 and plus 5. I'm down to my multiplication step. 3 times 9 is 27. So it would be 4 minus 27 plus 5. And then finally, I'm down to just the single operation of addition and subtraction. I got 4 minus 27 is negative 23 plus 5. I got negative 18 for number 2. Negative 18. Again, any questions? Joe asked a really good one. He figured it out. Anybody else with a question? Maybe on number 2. Okay then. Number 3. Number 3, the instructions say to simplify completely. And within this, do you guys see any distributive properties? Because we want to do those first if there are any. Yeah, there's 2 of them. The negative 3 gets distributed and the 8 gets distributed. I've said this 1,000 times, and still there's some folks that will make a little mistake here. It's just proof that you got to really focus and pay attention. As I distribute the negative 3, almost nobody ever messes up the first term. It's negative 21. But people will sometimes make a mistake on the second term. What should be the very next symbol that I write? Because a negative times a negative is a positive. So it should be plus 3x, right? Plus 3x. And then plus 8x squared minus 8 as I distribute the 8. Look at what you have. Look what I have. Do a little comparison. Do we agree so far?
Yes.
Okay. You guys see any like terms that we could combine?
The negative 21 and the negative 8.
Those are like terms. Any other like terms?
No.
That's it, right?
Yeah.
So negative 21 plus negative 8 is? And then plus 3x plus 8x squared. Why can you not add the 3x and the 8x squared? Yeah, the variables really aren't the same. I mean, they both have x, but one of them is x squared. The other one is x. They're unlike terms. So you cannot add those because they're unlike terms. So this right here would be your final value, final expression. Okay, and lastly, number 4 is something we've been working on for the last week or so. We'll keep working on it. It says solve for x. It's an equation. What does solve for x really mean?
Get x alone.
Get x alone, get it by itself, figure out what value of x makes the equation true. These are all descriptions of what solve for means. So we got to get the x by itself. Any suggestions on what I could do? I got to get rid of the 3 and the minus 11. What do I do first, Joe?
Plus 11.
Plus 11 on both sides is right. So let's add 11 to both sides. I hope that you are in a good habit of writing that out. Don't just add 11 up here. Make sure you show it on your paper. So you add 11 to both sides. What is negative 11 plus 11? 0. And that's the whole point. We wanted to get rid of it, so it's gone. So you just get a 3x over there. 13 plus 11 is 24. How do I get rid of that 3? Chase? Divide by 3. So dividing by 3, these cancel out to be a 1 using that inverse property of multiplication, essentially. And 24 over 3, of course, is 8. If you wanted to check that, you could take the 8 and plug it back in where you see x's and see if it really makes it true. I think you would find that, yes, it does make it true. Okay. Overall, look at everything that I've got. Look at the answers. Look at my work, my steps. I hope that your paper looks a lot like mine. If all you have are answers, we could have an issue, right? So please make sure that you're showing process, communicating what you're actually doing. Should be
Number
nice.
1, I didn't have any work because I just.
I think so. Hey guys, listen up, please.
Yeah.
I think for number 1, I think it's totally reasonable that you would not show any work on number 1 because it's just a single operation, right? It's just plus minus this and minus that and whatever. I think it's totally reasonable. I think number 2, it's pretty unreasonable to just like have answer. Just a little too much going on there. If you want to get it right, you probably show a couple of steps minimum. 3, probably just a couple of steps. You just basically the distributive property, then an answer, a couple of steps on number 4 for sure. It's a good question. Anybody else? Thoughts, worries, concerns? So if I gave you a pop quiz right now on this DMR, would you nail it? 4 out of 4? I hope that's the case. I really do. Genuinely do. Okay. Any other questions? Okay. Today is going to be our last day of solving equations and inequalities here in class. So you guys would flip forward in your notes, and we're going there. So let's flip ahead to our class examples. Everything today is going to be inequalities. We've done equations and a couple of inequalities the last few days. Today is going to be all about inequalities. And I only have 3 examples that I'm going to show you. I got 3 examples for you to work on, and that'll be it. So there should be time at the end for you to do some homework, do some Q&A, work on a retry, whatever. Okay, here we go. So example number 1 says solve. And the first thing, this is really, really good review. The first thing that I notice is that there are x's on both sides of the inequality. Do you see it? X's on both sides of the inequality. And so if you remember, when you're solving an equation, the first thing you really want to do is you want to make sure that everything that can be simplified is simplified. And so we need to get those 2 x's together. How would you guys propose that I could get the x on the left side together with the x on the right side? What do you think, Kyrie?
I would add 4x to 2x.
I think that's right. So I'm going to add the 4x to both sides. That is essentially going to move it from the right side over to the left side. So remember, whenever you're solving an equation, you want to get the stuff that can be simplified first. You want to do that first. So I think your suggestion is really good. 2x plus 4x is 6x. So we get 6x minus 9 is greater than 21. Now I would say that based on what Kyrie told us to do, everything that can be simplified is simplified. Now I can start working on solving. Suggestions on what I could do to solve.
Add 9.
Add 9. Yep, we're going to add 9 to both sides.
Good job, man.
So when I add 9 to both sides, I get 6x is greater than 30. And then to get the x by itself, dividing by 6 would be the way to go. So if I divide both sides by 6, I'm going to get x is greater than 5. And there's 2 ways to express the answer beyond just the x is greater than 5, and that's a fine way to do it. We could use a number line. So what kind of a symbol would go on the 5 on the number line? It's actually open. It's actually open. If the little extra line isn't there, the or equal to part, if that's not there, you leave the circle open. So it'd be open circle on 5. And then I need an arrow to go either right or left. Which way do you think it goes? Right. To the right, yeah, because we are talking about numbers that are bigger than 5, and all the numbers to the right on the number line are bigger than 5. Okay, so that would be our answer graphically. And then using interval notation, I only put this in here for WebAssign. I just want to tell you, on a concept quiz or maybe a summative assessment later on, I will not ask you about interval notation. I'm simply showing this to you because it is a thing, and it's definitely a thing on WebAssign. You've seen a few of them, right? So the interval notation here would be parentheses what?
Bin.
Nope. You
Five.
put the smaller one first, comma,
Comma.
infinity, and then you always have to put a parentheses on infinity because you can't actually get to infinity. Sir?
Isn't there like a different way to do interval notation where there's a bracket, like a square bracket?
That's if you have a closed interval. I think we'll get to one of those here in a little bit. Yep.
But the infinity always has the like.
Infinity has to be rounded parentheses. Has to be, every time. Because the bracket, like you're talking about, Joe, the bracket means that it includes that. It's or equal to, and you can never include infinity as part of your answer set because it's not even a number.
Right.
So infinity just means that you're increasing without bound. There is no end to it. So that's why it's open. Fantastic questions. Anybody else? Really, really good. Okay, we're moving on to number 2 then. So number 2, a little more complicated, right? So remember that the goal here at the start is to simplify before we get worried about solving anything. So we're going to simplify before we solve. Does anybody see any stuff that could be simplified? What do you see? Distributive property twice, right? There's 2 of them. So I see a 3 that could be distributed, and I also see a 7 that could be distributed, and we want to do both of those. Before we solve, we have to simplify. Okay? Before we solve, we have to simplify. So it's going to be 2x, and then Aiden, if I do that distributive property, what would result on the first one?
6x plus 6x plus 9.
Plus 9, very good. And how about the second one? Keep going.
7x plus 7 plus 1.
Make sense? So she did a nice job with the distributive property. And now that we've done the distributive property, you can see that there's a whole lot more that could be simplified, right? A whole lot more. There's some like terms. Yeah, I agree. So 2x plus 6x is 8x. You get 8x plus 9 is less than or equal to, what would the right side look like? 7x plus 8. That's right. Okay. So then, to finish this off, I still haven't simplified all the way. There's x's on both sides. Suggestion, Joe?
Subtract the 7x.
I agree. We're going to subtract that 7x over. That'll get my x's together. And once I've done that, now I actually am simplified. So it would be 1x, plus 9 is less than or equal to 8. So all that work that we just did is just a matter of simplifying, kind of like you just did on your DMR, right? You do some distributive properties, you add some like terms, and we got all the x's together, and now it's time to solve. So, Anna, what do you think? If I was going to solve this, what would be a first step?
Subtract the 9.
Subtract the 9, right? Because it's already 1x, right? So we definitely want to get rid of that 9. So minus 9, excuse me. That would give me x is less than or equal to negative 1. And that's it, isn't it? That kind of worked out nicely. No division needed because they're already just 1x. Okay, so then on my number line, what kind of symbol goes on the negative 1? It's a filled in or a closed circle. Yeah, so I will fill it in. Remember, that means that it includes negative 1. Since we have that or equal to, that's what that means. We're including it. And then the arrow would go which way? To the left, because we're talking about numbers less than or equal. Oops. Let's try that again. That's a little better. Less than or equal to negative 1. What about interval notation?
Isn't it bracket or the infinity parentheses like square bracket on the one?
So I agree with square bracket on the negative 1, like squared off, like a bracket, right? So it's negative infinity for the low value, but it's got to be parentheses there. So it's a rounded parentheses, negative infinity, comma, negative 1 with a squared off bracket, right? The pointy bracket. That's because this answer set includes the negative 1, but you can't actually include negative infinity. Okay, again, look at what I've got up there. Hopefully you took some good notes. Do you have any questions on any of those steps? All right, so here's my final example to show you today. It is right here, and this is what we call a compound inequality. So this is 2 statements in one. Notice how there's 2 inequality symbols, right? On the left side, there's a less than, and on the right side, there is a 27, or is it less than or equal to 27? This is 2 statements in one. So this is a compound statement like this. Like, have your parents ever said, hey, please clean up the dishes and go to bed? They're asking you to do both things, right? Or please get dressed and go to school, whatever. They're saying get dressed and go to school. You got to do both. So this is saying that negative 12 is less than 3 parentheses x minus 1, and that is less than or equal to 27. There's two different statements being put together here. And so because there are two different statements, we've got to handle this just a little bit differently. So there's a couple ways to do this, and maybe we'll look at both ways, I suppose. Does anybody see any simplifying that can be done here? You could distribute distribute in the middle. The 3 could be distributed. So the 3 gets distributed there and there. This gives me negative 12 is less than 3x minus 3, which is less than or equal to 27. So again, this is called a compound inequality. It's two statements in one. Remember, the goal is to get the x by itself. That hasn't changed. Any suggestions on what I could do first if my goal is to get the x by itself? See, the x is right in here.
Minus 3 from all sides.
Say again, Noah?
Subtract, or plus add, yeah.
Add 3. So here's the thing. If I add 3, as you guys know, if I add 3 to one side of the equation, I've got to add it to the other side. But aren't there like two other sides? I got to add it to both other sides. So I'm going to add 3 to this and this as well. Because it's two different statements, you've got to add the 3 instead of just twice, one each side. There's actually 3 sides to this. That's going to give me negative 9 is less than 3x, which is less than or equal to 30. The x is not by itself yet. What do I need to do to finish?
Divide by 3.
Divide by 3. So again, kind of like we did a second ago, if I divide one side by 3, I've got to divide the other side by 3, except there's two other sides, right? So I have to divide this by 3 and that by 3. All of them. All pieces of this have to be divided by 3 to maintain balance. This gives me then negative 3 is less than x, which is less than or equal to 10. So then, how do I graph this? Let me ask you guys. What kind of a symbol goes on the negative 3? Open. Yep. What kind of symbol goes on the 10? Closed. Agreed. And does anybody know what happens with the rest of it?
A line in between.
It's a line segment in between. Yep.
Because x is greater than 3.
It's between them.
Less than
Yeah, it's bigger than negative 3, but less than or equal to 10. And so that's why x, whatever it is between those two numbers. Okay, so you can have a mix. You can have an open and a closed and an open, a double closed. It can be any combination of the two. Question? Let's talk about the interval notation. So because we're open on negative 3, what kind of symbol would go with that? Regular parentheses, yep. So it'd be regular parentheses, negative 3, comma, 10. And what kind of symbol would go with the 10?
Bracket.
That's the bracket. So again, I want to be as clear as possible. You see this on your web assign. You will not see interval notation on a concept quiz or on like a final exam or summative assessment or anything like that. I only show this to you because I want to help you navigate the web assign. That web assign makes you do it. I couldn't find any examples in web assign that didn't make you do this, so I want to make sure you could do it.
Thank you for trying.
Absolutely. But you know what? The other thing is this will set you up for success in Algebra 2 and pre-calculus, whatever you end up taking, because they use this interval notation all the time. So it's certainly not a waste of time. You'll use it later. I just don't want to assess you on it right now. Okay. Any other questions? Okay, if you haven't already started to move forward, go into your practice questions, discuss with the neighbor, and we'll look at answers and answer any questions we need to. Take a few minutes and get going. It says solve, and you guys probably noticed, of course, that there's x's on both sides, right?
Mm-hmm.
So did you guys subtract x from both sides?
Yeah.
Think-
That's what I did.
Now, hold on. That is not what you have to do. That is something you could do. I'll do it the other way too. How about that? Okay, so if you do it this way, you end up with 5 minus 3x is less than negative 13, right? If we move that x over by subtraction. Now that we're simplified, we are ready to solve. So I think what I would do is I would subtract 5 from both sides, because it's a positive 5. To get rid of it, we need to subtract it. This will give me, I'll just come over here. It'll give me negative 3x is less than negative 18. And this is where this one gets a touch tricky, because what do I have to do to finish?
Where'd you get
3.
I've got to divide by negative 3.
Oh my gosh.
And anytime you divide both sides by a negative, what do you have to do? The The inequality gets flipped around. So instead of less than, now it's greater than. And then it's 6. So guys, here's the principle. Anytime you multiply or divide both sides by a negative, you've got to flip that inequality around. Makes sense on that 3 you said?
Yeah.
Okay. All right, what kind of symbol goes on the 6? Open on 6, arrow which way?
Right.
So look at what I have. Like I've suggested before, look at what I have, look at what you have. Let's see if we agree or disagree. So Nick, are you looking, Nick, hold on.
Oh, I got the sign.
Are you looking at this? Do you see how the symbol, the inequality symbol switched?
Yeah, I switched that.
Do you know why this inequality symbol switches? Why?
Because you flipped the order around.
Oh, let's look at the other one. Okay, so because I divided by a negative, can we look at the way the others suggested? Some of you said, I think that instead of subtracting x,
Oh,
I would like to add 2x to both sides.
is the answer 6?
X is greater than 6. Yep. Hey guys, this is totally valid, but what's different about this is you end up talking backwards, right? It's like a backwards statement. Here's why I would say that. You end up with 5 is less than negative 13 plus 3x. Then you probably added 13 to both sides. These are all really good steps. Giving you 18 is less than 3x. You divide it by 3, and you got this. 6 is less than x. The problem with this is it's really written backwards from the way that we would typically read these. We want to read the variable first. And so you could turn this around, and you could say that it really means x is greater than 6, because the alligator still needs to eat the thing that the alligator was eating. You could say it the other way. But the bottom line is we want numbers that are bigger than 6. That's why I suggest moving your x's to the left so we can kind of read it in the standard way, but it can be read the other way as well. Just be careful. All right, questions, concerns? So the interval notation would be open on 6, comma, positive infinity, open on infinity. So it'd be parentheses on both ends, 6 comma infinity for your interval. That work? Okay. Any questions? Number 2. Did all of you guys distribute on number 2?
Yeah.
That's certainly a way you could do it. So for number 2,
Be gone.
if you distributed, you would get negative 28 is less than or equal to 7x minus 14, which is less than or equal to 0. We got to get rid of the 7 and the negative 14. Which one did you get rid of first?
14.
Got to get rid of that minus 14. To do that, you need to do what?
14.
So we add up 14, not just to that side, not just to that side, all the sides, right? There's really 2 different statements, so it needs to happen 3 times. So this gives us negative 14 is less than or equal to 7x, which is less than or equal to 14. What's my final step?
Divide by 7.
Dividing by 7. This will give me my final statement of negative 2 less than or equal to x, which is less than or equal to 2. Okay, so what kind of symbol goes on the negative 2? Closed on negative 2. How about the 2? Also closed. So guys, if it's got the extra line, if it's got the or equal to in there, that means you need more ink to fill in the circle, so you fill in the circle. Okay. And then, of course, we just connect those two because x is between those, and so we want all the numbers in between. So again, if you wanted to test any of these out, you could plug in a -1, a 0, or a 1, and it should make a true statement. Interval notation. What kind of symbols went on the ends?
Parentheses and a bracket.
No parentheses at all, actually. A bracket and a bracket because they're both closed. They're both filled in circle. And then -2, comma 2 would be your interval notation. And again, don't stress too much about the interval notation other than just for WebAssign. It's not a big deal for a concept quiz or a test. Any questions, comments, concerns? Okay, then the last one, number 3. Number 3 is the last one. Notice how there's a lot of simplifying that needs to be done here. Bracket -2, comma 2, bracket. because we're closed on -2, closed on 2.
And then
So the-
circle.
Filled in on -2, filled in on 2, with a line segment between. Okay, simplifying here, there's a distributive property. This -2 gets distributed, bless you, there and there. So 5 minus 2x plus 6. You guys get the plus on that one? Negative times a negative, just like our DMR? Okay. Greater than, is greater than or equal, or just greater than 5x plus 7 plus x. There is a lot more simplifying to be done. Faith, what do you see? And that would give us?
6x.
Agreed. Anything on the left side I could combine?
Then we could do 5 plus 6.
Which is?
11.
Perfect. Okay, so we did a distributive property. Faith added some like terms. Jaden C over here. Any more simplifying that can be done?
You can do the negative, wait, you could take the 11 and take it to the 7.
You could, but I think there's something else. Let's deal with the x's
The negative 2x.
and the 6x, right? Like, what do you do with those?
You add.
Add
Let me make sure.
2x to the other side. So
Okay.
it's 8x.
Sure, we could add the 2x over. I don't know if you guys did it that way. That's certainly one way you could do it, and that works great. That'll give us 11 is greater than 8x plus 7. Notice if you do it that way, now the x is on the side that we're not used to it being on.
Yeah.
That's okay, we can handle that. Just be aware of it. To solve this now, we got to get the x by itself. What would you do first?
Subtract 7.
Subtracting 7 from both sides gives us 4 is greater than 8x. Thank you. And to finish it off, how do we get the x by itself? Divide by 8. So you guys get 1/2 when you reduced it? Again, that's a slightly uncomfortable notation. Maybe you want to write it like this. X is less than 1/2. That's the more standard way of looking at it, writing the variable on the left and the number on the right. So what kind of symbol goes on the 1/2?
Open.
Open on 1/2. So 1/2 is like right there, kind of in the middle. And then arrow which way?
To the negatives.
Yep, to the left, over there somewhere. Interval notation, what's the first thing you write? Parentheses, negative infinity, sure, comma. I think it's positive 1/2. And then parentheses because it's open. Okay. That's that. Any questions? If you can handle those, so like if you can honest to God handle those, you're going to do great on your concept quiz. Hope that that's the case. Guys, we got about 4 or 5 minutes here left, I think, so I'd be happy to answer questions, give any help. We figured out the whole Flash WebAssign thing. Can work on retry stuff. Be happy to answer any questions you have. So let's use our time wisely as we finish up.